Okay, so this is a question about changing in the internal energy. And this is the first law of thermodynamics. Change in the internal energy is combination of work done onto the system and Q, heat, given onto the system. And this is something that we have to figure it out. So this is your system, and it was saying that the system is absorbing this amount of the heat. It means that they show the direction of the Q going on to the system, and this amount is 35.8 kilojoule. And to make sure this is a positive because system is absorbing the system, so heat is going on to the system in this direction. So this is for sure. The Q was given. So now the question is about the work, calculation of the work, and this is an expanding from smaller volume to the larger volume. So the work is minus P external times the delta V, and the pressure here is against this is a 1 atmospheric pressure, so 1 atm, and the final volume was 24 and initial volume was 8, and the unit is liter. So at the end you will get the unit of this is 24 minus 8, that's minus 16 atm times liter. Okay, but I have this unit of atm liter and I need to convert that. So if you look at that, the hint was given here. atm times a liter is same as 101.3 joule, and that will give me 1620 joule, 21 joule, and then that will give me 1.62 kilojoule. One thing that I want to make sure is the sign stays here as a negative. Okay, sign stays here negative. So which is the work is, the system is expanding the work, so the work is done by the system. The amount is minus 1.6 kilojoule. 62 kilojoule. So therefore, the answer for this is 35.8 minus 1.6. That will lead me to 34.2 kilojoule. That's a total change in the internal energy, which is a D. Okay, so this is a question about using some kind of Hess law. So you're looking at this reaction, P4 becomes 10Cl2, 4PCl5 is a reaction. And now these two reactions are given on this side, and this one is same as here, so that's my starting point, but this one gotta go away, right? And this is not balanced, so this is something that I have to take care of, but this is what I want to keep, so I'm going to keep as it is, right? And looking at the equation on top, what I'm seeing is PCl4, and this is showing up here. So first I'm going to flip this equation from the top, so this equation becomes that, which is PCl3 and Cl2 becomes PCl5. Okay, and by flipping this, I have a new delta H reaction, which is now opposite sign of that 157. And now I need to make this one to be the case of the constant 4, so I need to multiply the whole thing by 4. So let me multiply by 4, 4, 4, which make this one multiply by 4 too. So this is a new reaction with everything multiplied by 4. So the heat of reaction is also multiplied by 4. So now I have this second reaction with this first one at the top, and I'm going to add it up, and to see that I'm going to say P4 stays in, and this 2 goes away, and you can get 10Cl2 becomes 4PCl5. So this is exactly what I'm looking for up there. So therefore, for this particular reaction, delta H reaction is essentially keeping 1207 kilojoule, and then adding another one, which is a minus 147 multiplied by 4. And if you do that, you will get 18 minus 1835 kilojoule for this reaction, and the answer is B here. Okay, so the last question is calculating what is the heat capacity of the calorimeter, and given that this is a reaction was given. So understanding this, the key point of this question is the meaning of this. The reaction, heat of reaction is based on how you write the reaction. And here, as far as aniline is concerned, 4 moles of aniline will give out this amount of the heat that is given up here. So the first thing is converting this, the mass. This is a mass, 6.55 gram of aniline. And I want to convert grams of aniline into the moles of aniline. 1 mole will weigh 93.13. So that will give me 0.07 mole aniline. Okay, just in case if you guys wonder what aniline structure looks like, it is a benzene with an NH2 amine group here. Okay, so I have this 0.2 moles of aniline, but as far as I know, the heat of reaction can give out minus 1.28 to the 10 to the 4th kilojoule divided by 4 moles of aniline. Right? So this is what from this equation what this really means. And multiply that. Okay, in my cases I have a 0.07 mole of aniline, and so therefore will cancel out, and it will give me the essentially how much heat is being released, and that's the one is about minus 224. So minus 224 kilojoule from essentially what it means is from 6.55 grams of aniline, right? So this from this I can get this amount. So the heat capacity, so this amount of heat was given is essentially the heat was given from this reaction, and then how much of your delta T. So in this case, all this amount that was given was, if this is your calorimeter, the heat was given from the reaction, so they actually switched the sign because this is an amount of the heat was given onto the system, and your delta T was 32.9 degrees C. And if you do that, you will get about 6.8 kilojoule per gram C. So therefore, answer for this is a B.